recognize what mistake was made, didn't know how to word it. Does anybody have any questions over these? Pretty simple. So everybody's good to go. All right, great. Then we're going to move along today to something that you're probably not going to absolutely love. Still equations, but they start out as word problems. Y'all love word problems? Huh? Is it your favorite? Word problems, Gabriel. So when we talk about mathematical operations and the word problems and what they mean, there's obviously a connection. So let's talk about some easy ones that you guys I know are absolutely familiar with. For example, yes. Oh my goodness. Not bringing your homework, not bringing a pencil. I'm gonna have to hurt you. You know? There you go. Alright, so four mathematical operations that we're very familiar with would include which four? Adding, subtracting, multiplying, and dividing. So let's start with adding. Y'all tell me some words that could indicate addition. Sum. Sum is one, for sure. Sum usually indicates that there's multiple things that you're going to add together. So sum's a good one. What else? Increased by, right? Increased by is a big one. More? Huh? Yeah, just straight up plus, right? Added to. Any more? More than? More than might be, if you say something like, she has 7 more than I have, that's plus 7, right? So that's one. Okay, let's go to the next one, subtraction. What are some words that indicate subtraction? Huh? Less than, and that's tricky, we'll talk about that. Decreased by is a big one.
Take away.
You could say take away. I don't hear that one as much in a word problem, but it is.
Mr. Bingham, but
He is right now, Mr. McWhorter's class. Right?
okay.
He's
Where's
coming
that?
here 5th.
Where is that?
You go down and take a left. It's the 3rd classroom on the left.
Okay, thank you.
Or second. Second or third? Second. Okay. So decreased by. What else? There's one word that you can actually say in 2 different ways, and they mean 2 different things. That's subtracted by and subtracted from. Those actually are indicating 2 different ideas, aren't they? If something is subtracted by something else versus something being subtracted from something else, you're still saying subtracted, but the to and the by, or the by and the from, that indicates a difference. Okay? Anything else that y'all can think of? Did we say minus? Minus would work. Okay, let's move on, because there might be more. How about multiplication? What are some words? Oh yeah, we left out difference. The difference of means subtraction. Okay, what about multiplication? What do we got? Product. Times. They might say multiple of. They might use other words like, what if they said twice a number? What is that indicating? You're multiplying by 2. So they might use a word like that to indicate multiplication. Okay? Y'all think of anything else for multiplication? All right, how about division? What are some words that you see with division? Huh? Half? Okay, have. What else? You could say 1/2 of something. What does 1/2 of something mean you're doing? Dividing by 2. It could also indicate that you're multiplying by 1/2. Multiplying by 1/2 and dividing by 2, same concept. What else could be division? One word starts with a Q. Huh? Quotient. Quotient. Y'all know that one? They might literally say divided by. Okay, now, out of these four, and there might be some more that we have not addressed that we'll come across, and when we do, we'll discuss it. But out of these four, there are two of them where order is extremely important, and therefore you have to be more careful with them, right? What two am I talking about? Subtraction and division. And division's usually pretty straightforward the way they state them. Subtraction's the one that sometimes tricks people. Okay? Subtraction will get you if you're not careful. And there's a couple of them that will get you, okay? I already talked about the subtracted by and the subtracted from. Just pay attention to the order of those. Okay? If I say 25 is subtracted from 8, what does that mean? What would that look like? That means 8 minus 25. But if I change one word and all of a sudden I say that it's subtracted by 8, how would I write that? 25 minus 8, exact opposite. So you got to be careful with that one. Okay, subtracted by or subtracted from. The other tricky one is less than. Let me show y'all less than. In fact, I probably should do it on, let me do it on here. That way, fifth period we'll be able to see it. So when I use the term less than, this is the way I want you guys to consider it. Let me go on down here. If I were to say, for example, 5 less than a number. A lot of times people's minds will immediately think, hey, less than means what? Minus, right? They'll say less than means minus. So 5 less than a number, they'll want to write it 5 minus a number. And is that right? No, that is not right. Okay? That's wrong. 5 less than a number is not written in that order. So here's the best way I can remind you guys to understand this, so it makes logical sense to you. If I were to say that your little brother is 2 less than your age, and let's say most of you guys are 16, what is 2 minus 16? Huh? Is your little brother negative 14 years old? That doesn't make logical sense, does it? See, if I say that your little brother is 2 less than your age, I don't do 2 minus your age. I do your age minus 2, right? 16 minus 2 is 14. Your little brother's 14. Can y'all remember that? Less than means I am subtracting that value from something. So 5 less than a number actually means x minus 5. That's the one that tricks people the most. Okay? Because people remember that less than means minus, and then they just follow the order. 5 minus a number. But it's actually a number minus 5. So be careful with that one in particular. The rest of them are pretty straightforward. Like, for example, if they ever use the word difference, what is that indicating? It means subtraction. So you're going to go ahead and write your minus sign down, and then whatever order they give you, you put them in those locations. Whatever order they give you. So that one you don't have to be as careful with because they're going to specifically give you the order they want them to subtract. Are you with me? Okay, so let's look at some of these that, you know, like I said, we love word problems. Taking a minute. So we're going to fight through some of this stuff. Here's the real trick to solving these equations that are using word problems. Breaking the problem down and not getting overwhelmed by reading the entire thing and trying to see the equation by reading the entire thing. Now, I would recommend you read it just so you can kind of get a sense of all the stuff, but then before you start writing it, start breaking things into pieces instead of trying to see the whole thing at once. So here's what this one says. Somebody read it. Read it nice and loud. Not all at once, please. It got really confusing here because everybody was wanting to read all at the same time. Is that weird for me to ask you guys to read in math class? I honestly don't know if I've done that in a while.
This is actually.
Y'all are busy bees.
Yep. This is for you.
Yeah, I knew it was coming. I just didn't know who it was for.
Oh.
Thank you so much.
You want some warning?
Hey, one more thing. I'm joking.
Bye.
Bye. Alright, so no one wants to read. I'll read. The product of 7 and a number increased by 3 is equal to twice the number subtracted from 39. See, when you read that whole thing and you start thinking, okay, what's this equation? You're going to get confused, so just break it down. Alright, so let's start right off the bat. The product of, what does that mean? We're multiplying. Well, what are we multiplying? 7 and a number. How do I multiply 7 and a number? What does that look like? 7 times x. 7x. Okay, that's not too bad, right? Let's keep on cruising here. Increased by 3. What does increased by mean? We're adding, right? So to 7x, we are adding 3. And then it says is equal to. Isn't that key? What does that is equal to tell me? Put your equal sign. Okay, that divides the problem into two sides. Now let's see what's on the other side. Twice the number. How do I write twice the number? 2x. And then here's the key. Subtracted from 39. Subtracted from 39. If I'm subtracting 2x from 39, where does 39 go? Front or back? It goes front. So I need to just quickly, if y'all wrote that, just quickly erase it or jam in that 39. And what does subtracted mean? Minus. So we're subtracting 2x from 39. Y'all see anything else here? Then this is my equation. Okay? 7x plus 3 equals 39 minus 2x. It's not that bad, right? Now, it might get a little worse. But right now, we're good. Yeah? Do I have anything on the left side to simplify? No? Right side? No. Step 3, do we have variables on both sides to get together? Yeah, I've got the 7x and I got the negative 2x. Which one do I like to move? I like to move the smaller one, which is the negative 2x. How? I'm going to add 2x. Guys, what's 7x plus 2x? So we have 9x plus 3 equals 39. Does everybody follow that? All right, so now we're just solving a pretty simple equation, right? What comes next? We're going to subtract 3. Guys, what's 39 minus 3? And then lastly, divide by 9. And 36 divided by 9 is? So x equals 4. And that's it. We wrote the equation. We solved the equation. Okay? Questions? Okay, let's keep on moving along. Let's look at number 5. Number 2. I don't know why I said number 5. I think it's because number 2 says 5 right off the bat. And I saw that. So, I want to do this one because right off the bat, what's it got? It's got that word that always confuses everybody, the less than. For some reason, that just causes issues. We see 5 less than, and people want to go 5 minus. But 5 less than means what? 5 less than means what? Minus 5. Now, what are we subtracting 5 from? Twice the number, 2x. So 2x minus 5. And then what does it say? Is equal to, there's going to be my dividing line, essentially. And now we're ready for the right side. Now the right side has another little trick to it. Right off the bat, what does the other side say? 1/2 the difference of. Okay, pause. We're about to do half a difference. Okay, so stop with 1/2. What does it mean to do 1/2 of something? It means I can either divide by 2 or I could multiply by 1/2. Now, if I were to say to you guys, hey, what's 1/2 of your age? Most of you guys do what? You divide by 2, right? So let's do that. We're going to divide this right side by 2. That's what 1/2 means. But we're doing 1/2 of, we're dividing what by 2? We're dividing what by 2? The difference of, what does that indicate to me? Subtracting. Well, what am I subtracting? The difference of what? So 3 times the number is 3x, and what? 13. So it told me my order. When it says the difference of, you just follow the order. 3 times the number and 13. So it's 3x minus 13. So here's what my word problem said. 5 less than twice the number, that's 2x minus 5, is equal to 1/2 of the difference, so divided by 2, what? The difference, subtraction, of 3 times the number, 3x, and 13. So 3x minus 13 divided by 2. Now, in solving this problem, we've done this already enough. What has to go first? We've got to get rid of our 2 that's in the denominator, right? Got to get rid of that denominator. It's being divided. How do we get rid of it? When I multiply by 2, it'll cancel on the right, but what will it have to do on the left? It'll have to distribute. That's the exact word I was looking for. It has to distribute. What is 2 times 2x? And what is 2 times negative 5? Negative 10. So it becomes 4x minus 10. And on the right side, I'm left with 3x minus 13. Because the 2's cancel. And now I've got a pretty simple problem, don't I? I need to get my variables together. Which one do I like to move? I like to move the smaller one. In this case, that's the 3x. How will I move that 3x? Subtracting. What's 4x minus 3x? 1x, or we could just write x. Right? You don't need the 1x. It's understood. And then what else comes down? Minus 10 equals negative 13. So we're almost done. We got one more step. What is it? We're going to add that 10. What's negative 13 plus 10? Negative 3. Let me ask you all a question. I like to do mental math, and I like to encourage you guys to do it as well. Me personally, if I were doing that in my head, I wouldn't go negative 13 plus 10. I would do the positive number first, and I would do 10 minus 13. If you're doing that in your head, does negative 13 plus 10 make just as much sense as 10 minus 13 to y'all? It does? It doesn't me. I'd way rather, like, 10 minus 13 just makes more sense than negative 13 plus 10. But maybe I'm the weirdo. Does that not make more sense to you guys? I don't know. So it's negative 3. Anyways, that's the answer. So what do you think? Y'all doing good with that? No? Okay, where's the struggle? Do you have a specific place? Not really? Just need more practice? Okay. All right. Because I think you can get there. You just got to kind of break it down. Look at all your parts, just kind of one at a time until you put it all together. Okay? All right, you'll get it. Let's switch gears just a touch. Still word problems, but this one has a difference. I'm going to read it, and I want you guys to tell me what's the difference in this problem and the 2 before it. One number is 9 more than twice another number. If the sum of the numbers is 129, find both numbers. Why is this one different? That's right, Emma. There's 2 different numbers. Now, that doesn't mean there has to be 2 different variables. Here's why. One of them is being directly compared to the other. Okay? In fact, here's how they defined them. One of them they called one number. What do they call the other one? Another number. I want everybody to read the problem again and answer this question, okay? Which one is being compared to the other? I've already named them. One of them's called one number. One of them's called another number. I want you to look at it and see which one is being compared to the other? Which is being compared to which? Keep going. Which is being compared to which? We've named them one number and another number. Which is being compared to which? It's important. I promise. Look at it. Which is being compared to which? Anybody? Go. One number is being compared to another number. When you figure that out, here's where this helps me. If one number is being compared to another number, I know another number. What is it? If we find what's being compared to, we know the value of that particular one. What is it? It's a variable. It's something. It's x, right? So another number is x. You see, one number is being compared to another number is x. You understand that? Does that make sense? Yes? Okay, now, here's why that helps me. Now, I can write an equation, or an expression at least, for one number. Because how did it define it? It is 9 more than, what's that mean? 9 more than. It means plus 9 or 9 plus. It's 9 more than what? Twice the number we just defined is what? X. So it's 9 more than twice x. So how do I write one number? 2x plus 9. Or 9 plus 2x. Y'all know that 2x plus 9 and 9 plus 2x is identical, right? So look, we have defined our two numbers. One number was compared to another number is x. One number was defined as 9 more than, plus 9, twice the other number, x. 2x plus 9. Now, we can solve the problem. How? What does it tell me about this problem? Brayton said earlier, sum means what? It means adding. It says, if the sum of those numbers is 129. How do I write that? The sum means what? Adding. And what are we adding? Our two numbers. What were our two numbers? 2x plus 9 was one of them. And what was the other? X. And if we add those, it equals 129. Does that make sense? Yeah? No? Okay, so let's combine some like terms. What can we combine here on this side? What is 2x plus 1x? So we got 3x plus 9 equals 129. Now what? We're going to subtract the 9. 129 minus 9 is 120. And then lastly, what's 120 divided by 3? So, another number is 40. How do I find one number? So I say plug it in. Plug it in. Very good. So 2 times 40, 80 plus 9. So one number was 89, and the other number was 40. Does that make sense? What do y'all think about that? Y'all feel okay? No?
I like it.
You don't like it?
No.
No fun? It's confusing? Okay, we'll get there. All right, just bear with me. It's tricky, yes.
I wanted to be
You mean the equation for one number? because you're not multiplying the other number by 9. You're just adding 9 to it. Does that make sense? 9x means you'd be multiplying 9 by the other number, but you're not. You're just saying it's 9 more than twice x. So you're just adding 9 to 2x. Does that make sense? You would only go 9 times x if 9 were being multiplied by the other number, but it's not. It's just being added to it. You with me? Okay. All right, let's go right below it, number 5. The length of a rectangle is 1 more than 4 times its width. If the perimeter of the rectangle is 62 meters, find the dimensions of the rectangle. So what are we talking about right here? What are we talking about? We're talking about a rectangle, right? And we know that all rectangles have a length and a width, right? So here's my question. Which is being compared to which? Read it. Which is being compared to which? Length is being compared to the width. So what does that mean? We know the width, don't we? If length is being compared to the width, we know the width, it's what? The width is x. Are you with me? If you wanted to call it another variable, you could. But I'm just going to go with x. The width is x. Because length is being compared to it. So we know what it is, x. Now, how is the length defined? How did they define the length? 1 more than, guys, what does 1 more than mean? Plus 1, or 1 plus, same thing. 1 more than what? 4 times its width. How do we do 4 times its width? 4x. So, the width was what it was being compared to, it's x. The length is 1 more than, plus 1, 4 times the width, 4x. 4x plus 1. Now, let's look at this problem from here. It tells me how to set it up right here. It says, if the perimeter. Guys, what does perimeter mean? You add up all the sides. How many sides are in a rectangle? 4. And we know them all, don't we? Because if this one right here is x, and I should use a different color, what's the one straight across from it? Also x. And if this one right here is 4x plus 1, what's the one above it? So here's what I know. I know that x plus 4x plus 1 plus 4x plus 1 all adds up to equal the 62. That's how you do perimeter. You add up all the sides. Now there's an equation, 2L plus 2W equals perimeter. And maybe you use that. It's the same thing. But here's what I'm left with. My like terms are 1x plus 1x plus 4x plus 4x. What is x plus 4x plus 4x? So I got 10 x's. But I also have this positive 1 plus 1. What is that? Plus 2. So I got 10x plus 2 equals 62. And now it's a simple problem, right? What am I going to do? I'm going to subtract 2, so 10x equals 60. And then I'm going to divide by 10. So x equals 6. So what does that mean? If x equals 6, what does that mean? My width is 6 by my length is 4 times 6, 24 plus 1. So my rectangle is 6 by 25. Y'all with me? Does that help a little bit? When I'm not comparing one number to another number, we actually have length and width. It makes it a little clearer, doesn't it? Again, what we need to remember is when I have multiple numbers we got to look at the one that's being compared to the other. That one is the one we define as x. Then we can write our equation, and it makes it, quite a bit easier. Okay? Questions? What time do we got here? Help me out. 20? Okay. We got a little bit of time. A little bit more time. Let's go to the back side. And let's see here. Let's go to number 8. We're not going to finish this whole thing up today, and that's okay. All right? I'm not going to rush it. So here we go. Kelly, Laura, and Tia sold boxes of cookies for a fundraiser. So all of a sudden, how many people do I got? I got 3. I got Kelly, I got Laura, and I got Tia. All right, here we go. Kelly sold 15 boxes less than Laura. Tia sold twice as many boxes as Kelly. If they sold 83 boxes of cookies in total, how many did each person sell? Okay, so here's what we got to figure out first. Before I do anything else, I got to figure out who's being compared to who, right? So Kelly is being compared to who? Laura. And Tia is being compared to who? Tia is being compared to Kelly. So who's at the bottom of the totem pole? Who is everybody being compared to? Laura. So what does that mean about Laura, guys? Laura is X. Y'all understand that? Laura is X. Okay? She's the one everybody else is being compared to. She's something. She's X. Now let's look at who's compared to Laura. Kelly. What does it say about Kelly? She sold 15 boxes less than Laura. Does that mean 15 minus X? No, remember, less than is that tricky one. It means Kelly is X minus 15. Correct? Are y'all with me on that? That's Kelly. Now, who is Tia being compared to? Tia is being compared to Kelly. What is Kelly? She's X minus 15. What does it say about Tia? Twice as many as who? And if Kelly was X minus 15, that means it's twice X minus 15. Okay? Does everybody follow that? So our first job when we have multiples, like 3, we got to figure out who is everybody originally being compared to. We define them as X, and then we start naming the equations for everybody else. Now, what does it say about all 3 of these? If they all sold 83 boxes, what does that mean if they all sold? If we added them all up, right? They all sold 83. Well, how do I do that? I take each of them and I add them all up. So I take X minus 15 plus X plus 2 times X minus 15, and all of that has to add up to equal 83. Does everybody understand that? Now, before I do this, what do I have to do? What's my rules of solving? Don't I need to get rid of that distributive property real quick? Now, I'm going to go ahead and just write everything down. I'll combine all the stuff that I can combine in a minute. But what is 2 times X? And what's 2 times negative 15? All right? So now let's combine our like terms. What's X plus X? Plus 2X more. So we have 4X. And then also, what is negative 15 minus 30? Negative 45. That all adds up to equal 83. Let's solve the problem. What do we do first? Add 45. So 4X equals, what's 83 plus 45? 128. Last step. And we're about to find out how many who sold? Laura. How many did she sell? She sold 32 boxes. Laura sold 32 boxes. right? So who do I check next? Well, it doesn't matter, does it? Because we know x is 32, so go plug it in. What's 32 minus 15? So Kelly sold 17 boxes. And then didn't Tia sell 2 times Kelly's 17? That's 34 boxes. So Kelly sold 17, Laura sold 32, and Tia sold 34. If you want to, you can always go back and add those up. What should it equal? It should equal 83. Did it? Anybody try it?
Yeah.
It does. Okay? It does. Questions about that one? Okay, we're going to do one more, and then tomorrow I'm going to save consecutive integers for tomorrow, and then here's what's going on. So tomorrow, as soon as we finish this worksheet up, I'm going to give you guys a little review, and you're going to have a quiz on Wednesday. Okay? A quiz on Wednesday. I was going to give the quiz tomorrow, but I want to save consecutive integers for tomorrow. So let's look at number 9. We'll do number 9, and then tomorrow we'll do 10, 11, and 12, and you should be good to go. All right, the measure of the vertex angle in an isosceles triangle is 6 less than 4 times the measure of the base angle. Find the measure of the vertex angle. Is that clear as mud? What are we talking about here? We're talking about a triangle. More specifically, we're talking about a what? Isosceles triangle. Can y'all remember the definition of an isosceles triangle? 2 equal sides. So look, guys, these are identical. Now, hopefully you guys remember, because it had 2 sides that were equal, the 2 angles that were at the bottom of that, those are called base angles, and they are equal, congruent. Y'all remember all that? So we know 2 of these 3 angles are the same. So let's look at what this says. The vertex angle. Now listen, if those are the base angles, guess which one the vertex angle is? The other one, right? The top one. That vertex angle is 6 less than 4 times the measure of the base angle. So which is being compared to which? Vertex compared to base. So guys, what's my base angle? My base angle is x. And how many of them are there? They're both there. They're both x. So the only one we need to define that's not x is the vertex angle. And what does it say? It's 6 less than. Guys, what does 6 less than mean? Does it mean 6 minus? No, it means minus 6. 6 less than what? 4 times x. So my vertex angle is 4x minus 6. My 2 base angles are both x. They're the same. Whatever one of them is, the other one has to be it. So they want us to find the vertex angle. Well, what do we know about triangles, guys? If I took 4x minus 6, and I added x, and I added x, what do we know about the 3 angles of all triangles? They equal 180. They equal 180. And that's how I solve this problem. So let's do it. Let's combine our like terms here. What is 4x plus 1x plus 1x? So we got 6x minus 6 equals 180. Then we're going to add 6. That's 186. Lastly, we're going to divide by 6. What's 186 divided by 6? So my base angles are both, how big? 31 degrees. Now, obviously, I didn't do a great job drawing that, did I? But it didn't matter. It was just visual. Now, the vertex angle is 4 times 31. What's 4 times 31? Minus 6. Say it again. 118 degrees. So 118, 31, and 31. I think it just asked about the vertex angle, so it's 118 degrees. Okay? Remember, always answer the question that it asks. All right? And there you have it. We're going to We're going to do consecutive integers tomorrow, which I think you guys will be really good at. You'll get it. It's easy, really. It confuses people at first, but it's really not hard. And as soon as we do that, as soon as we finish that, I'm going to give you guys a little review for a quiz, which I don't normally do, but it's the first one. I want you to do good. So y'all don't have any homework for me tonight. You're the greatest, Mr. Costello. I know. You guys are too nice. And now we're done talking to myself. But I am. You're right. I know you were thinking it. Weren't you, Ian? Were you thinking it?